A very good morning to all. The next chapter in the discussion here is semiconductor devices. From this chapter, what are the things we are going to concentrate here is about a PN junction diode and a logic gates. According to the weightage in NEET here is for three questions they used to ask in this one 6% of weight, but in MSET only two questions they are going to ask in this case. Okay, the first question here is the PN junction diode, the thickness of the depletion layer. Yes, what they have given here is depletion layer in case of PN junction diode. In this case, the depletion of the depletion layer of the PN junction diode here is 2 into 10 power minus 6 meter, and barrier potential is 0.3 volt. What they are asking here is the intensity of the electric field. First one, you try to understand here what you mean by PN junction diode. This is the P region and this is N region. Here is holes is maximum in this case of a P region, and N region here is electron is maximum. Suppose see here barrier potential here is 0.3 volt, and the thickness of the depletion region here is 2 into 10 power 6. So intensity of electric field, how you can find out here is, see this one, intensity of electric field here is a barrier potential to its depletion layer. Once you are going to have this one here is zero point 0.3 divided by 2, what you are going to have here is 1.5 into 10 power 5 volt. See, what you are going to have only zero point 0.3 volt barrier potential, but what you are going to have the electric field in this case here is 1.5 volt. So here electric field is maximum than the depletion region is trying to prevent the further movement of electron from the N region to the P region and holes from the P regions to the N region. But here in this case the intensity of electric field is maximum when compared to the barrier potential. So that what happened here is the electron starts to move towards the barrier region, and here the depletion region which is having a less potential, so the electron which crosses towards the region, so the depletion region will decrease. So the value here is 1.5 into 10 to the power 5 volt. In this case the electron will be moving from, see, electron here and holes are here, but in this case see this one which has been connected to the potential, this one you just see here. So that what happened here is, so electron will be moving towards this region to here, and holes are attracted towards the negative charge also. So electron will be moving from N side to P side. So answer in this case here is this one. Okay. The next question is the relationship between the number of free electrons in a semiconductor and the temperature. Now, for this one, what is the relationship between the number of free electrons, that is about N, and the temperature here is, see this one, N is directly proportional to A into T power 3 by 2 E power Eg by, that means Eg divided by Kt, where A is about the area of cross section of the substance, and Eg is about a forbidden energy gap, K is about a Boltzmann constant, and T is about absolute temperature. For in case of a conductor, let me tell you in this case, for in case of a conductor, I just write on here, for in case of conductor, this forbidden energy gap I just mentioned here, which should be less than Boltzmann constant's value here. For this one, Kt value here is, I just mentioned here, for this one Kt value here is 8.62 into 10 power minus 5. That is a electron volt. This energy is in electron volt per Kelvin. This one I just mentioned, electron volt per Kelvin. Suppose in case of this is this one in case of conductor I just mentioned here. This one in case of conductor. Suppose in case of semiconductor I just mentioned here. In case of semiconductor, in case of semiconductor, this one Eg value will be equal to, so the Eg value will be equal to Kt. See, you just substitute the values over here, Eg and Kt will become 1 by 2, and E power 1 by 2, that is root of E, this value will become constant, and area of cross section will also the same, that also constant here. So N is directly proportional to T power 3 by 2. That's what they have given in this case. For semiconductor, this is about the constant. Suppose for in case of an insulator, the same one I just mentioned here, for in case of insulator, you just remember this one. Eg value here is, for this one, Eg value which should be greater than Kt value. So based on this one, for the semiconductor, here the value N is proportional to 3 power T power 3 by 2. Question here is a semiconductor has a equal electron and hole concentration. They have given the value here 2 into 10 power 8 per meter cube. Now, in this case, in semiconductor, electron and hole concentration are similar. On doping in this case, adding impurities to the pure form of semiconductor is called as a doping here. Now, in this case, if you are going to add pentavalent impurities, pentavalent means 5 valent impurities. If you are going to add this one in a pure form of semiconductor, this will become a n type of semiconductor. Suppose if you are going to add trivalent impurities, this will become p type of semiconductor. In this case, you are going to add some electron concentration. We are going to add some impurities, so electron concentration has been increases this value. Then calculate the new hole concentration. The electron concentration they have given, and the holes concentration is what? See, if you combine with the electron and hole, that value here is Ni, both combined together. And only holes concentration means N of H, electron concentration N of E. So in this case, I just mentioned here, both electron and holes concentration, they have given the value. And if you are going to add some impurities, that is, you are going to increase this one. This is the value here. For this one, we are going to find out number of holes. So this is about the formula n of I square equal to Ne plus Nh. From this one, already we know this one Ni square that they are given, and the electron concentration also they are given. From this Nh, you just substitute the value and cancel this one. What you have seen, 2 square, this is 10 power 16. 10 power 16, 10 will be cancelled, only 6 is there. 2 square is 4, 4 will be cancelled here. So what you are going to have here is 10 power 6. So answer here is 10 power 6 per meter cube. Of the following junction diode are forward bias. Okay, now before going to that, the junction diode, you have to understand this one. Let me tell you here the concept. See, this one I just mentioned here. In case of diode, see, I just mentioned in this one. This is about the diode here. This one is P type of semiconductor, and this one here is N type of semiconductor. Same in all the diagram you can mention here, P type and N type. If P type of semiconductor is uh, connected to the battery, that is about a positive terminal of battery. See here, this is positive and negative terminal, and a positive terminal of battery is connected to P type of semiconductor. And see here, positive terminal of battery is connected to P type semiconductor, and negative terminal of battery is connected to N type of semiconductor, is called as forward bias. Similarly, in this case, if negative terminal of battery is connected to P type of semiconductor, positive terminal of battery is connected to N type of semiconductor, that is reverse bias. This is one type. And another one is P type of semiconductor, which should be given a maximum potential when compared to the N type of semiconductor. That constitutes forward bias. Simply, I will tell you, if potential is maximum given to P type, that is called as forward bias. If potential maximum is given to N type, that is reverse bias. Now coming to this examples here, see, 2 is maximum or 6 is maximum. 6 is maximum here. So maximum value is given to N type of semiconductor. So it is called as reverse bias. Coming to here, minus 2, minus 4. Here which is maximum here, minus 2 is maximum. So minus 2 has been given to P type of semiconductor, less value, the minus 4 which has been given to N type. So this is forward bias. Coming to here, 3 and 1, which is having a maximum value, 3 value which has been given to past P type of semiconductor. So this is forward bias. Minus 7, minus 2. Minus 2 is maximum value. So this is reverse bias. These two are reverse bias and these two are forward bias. See, from this one answer here is B and C are the forward bias. Similar like previous problem here, which of the following junction diode are reverse bias? See, reverse bias in the previous one already I told, in a PN junction diode, if P type of semiconductor is given a maximum potential than a N type of semiconductor, that is forward bias. If N type of semiconductor is given a maximum potential than a P type of semiconductor, that is reverse bias. See, coming to here, this is connected to the earth. Earth in this case, this is 0 volt and this is plus 2, which is maximum here is plus 2. So which has been given to N type of semiconductor. So this is reverse bias. Coming to here, minus 6 and 0. Minus 6 is less, 0 is maximum. Here is maximum value given to N type of semiconductor. So this one also B also reverse bias. Coming to here, this is 0, this is minus 8. Which is maximum, 0 is maximum. Maximum has been given to P type. So this is forward bias. So again, this is 3, this is 0. 3 volt has been given to P type semiconductor. So D also forward bias. In this case, A and B are reverse bias. So answer here is A and B. C and D are forward bias. Here is the current from the below circuit if forward bias of resistance. See here, resistance in the resistance of the diode is 30 ohm will be. See this one, for this to better understand, this is forward bias. Already they have mentioned this one. This is forward bias in this case. This is P positive and this is negative here. Now from this one see from here, so what you are going to mention here is this is about the potential of 5 volt and this is 2 volt potential here. Now I just mentioned what you are going to find out here is, hope you remember this one. Suppose in the resistor which are collecting over like this is VA and this is VB here. How we are going to find out the potential difference across here is VA minus VB. So this is about the concept, that one will be equal to 0. That is about the total potential. Similar concept in this case I just mentioned here. First one VA here is plus 5 volt. So I just mentioned here plus 5 volt. Next one is, see already they have given in this case this is about 10 ohm of resistor. Now see in this case this is about the electron here. See electron will be moving from, this is positive and negative here. Electron will be moving towards from negative to positive, so that the current, so this is about the electron movement, so that the current will be moving from this side to positive to negative. See once the electron, hope you remember this one, this is about the resistor I just mentioned here. This is about the resistor and this is about the current flow direction. Once you are going to measure the potential, that is about V here I just mentioned here. Potential we are going to measure in clockwise direction. Hope you remember in the current electricity. This one in this case what you are going to mention here is this is about the resistor. So the potential here is minus IR. Similar concepts here. See now I am going to measure the potential difference towards this direction, that is about the current direction here. So I just mentioned here minus of I into R here is, one is about 30 ohm and 70 ohm, both are connected in series. So I just mentioned here 30 plus 7 into I, and VA, this one here is minus of VB. VB here is minus 2 volt. That one will be equal to 0. So this one I into R, according to Ohm's law, what you are getting here is this is one also a potential. 5 minus 2 here is 3 volt minus of 100 I, what you are going to have, that one will be equal to 0. See from this one 100 I will be equal to 3 here. Then from here I is equal to 3 divided by 100. What you are going to have here is 0.03 ampere. So answer here in this case 0.03 ampere. Is a cell of EMF cell, that is about the battery which is having a EMF of 4.5 volt, is connected to the junction diode which is having a barrier potential is 0.7 volt. And another, in addition, what they are given, if the external resistance in the circuit here is 190 ohm, then the current in the circuit, what they are asking in this one, they are asking about the current. Now I just draw a diagram for this one to understand better here. See this one, first one is about diode. I just mentioned here, this is about the diode. Diode which is having barrier potential here is 0.7 volt, and this one see here, and which has been connected to the cell I just mentioned here, cell which is having a potential of 4.5 volt. And the next one additional what they have given here is, if an external resistance, see this one I just mentioned here, a external resistance of 190 ohm, this one I just mentioned here 190 ohm, which has been connected in the circuit. See I just mentioned here in this one, what they are asking, what is the current. See this is about the electron flow. Electron will be moving towards this direction. Once the electrons are see here, electrons are moving towards this direction, and opposite to the direction there will be a current flow. So I just mentioned here current flow in this direction here is, I just mentioned as, see this one here is current flow will be along this direction. See here, now in this case according to Ohm's law I just mentioned here, V is equal to I into R. What they are asking in this one, I value. See from this one, this is about V here, and V here is, this is about EMF of the battery E, and this barrier potential that will be try to opposes the flow of electron from the N type of semiconductor to P type of semiconductor, and holes from the P type of semiconductor to N type of semiconductor. So I just mentioned E minus, this is about the battery potential, I just mentioned as V divided by R, that one will be equal to I. Hope you remember this one. This one E is about EMF of the battery and V is about the barrier potential. Now substitute the value here. E here is 4.5 and minus of barrier potential I just mentioned here 0.7 and divided by resistance what they have given here is 190 ohm. That one will be equal to I. Now I just mentioned here this one I just mentioned here 4.5 minus 0.7 here is 3.8 divided by 190 here, that one will be equal to I. Now in this case I just multiply and divided by 100 here, so what you are going to have here is 3.8 divided by 100, and this one I just mentioned here 190 into 100 here, so that one will be equal to I here. So this one I just mentioned here 3.8 here is 380 divided by 19 into 10 power 3 I just mentioned here. Say this one I equal to, see from this one I just mentioned here, see from this one 380 you can mention here, this is for if you cancel here, this one is for 20 times. So what you are going to have here is I is equal to 20 divided by 10 power 10 power 3 here, that one will be equal to I. So I just mentioned here from this one I is equal to what you are going to have here is 20 into 10 power minus 3 ampere. So my 10 power minus 3 here is milliampere. So answer here is 20 milliampere. Similar problem what we have seen previous one. See here previous one they are asked about current, but in this case they are asking about resistance. That's all, both are similar concept here. See what they have given, forward bias current they have given, that is 100 milliampere, and germanium with diode here is germanium 100 milliampere, and the battery they have given, and the resistance value they are asking us to find out this one, and the barrier potential they have given 0.3 volt. See for this if you want to understand this one, the similar concept what we have seen in the last problem, similar like this I just mentioned here, V is equal to I into R. Already according to the Ohm's law, V is about see here V is about barrier potential, and this one battery here is I just mentioned here E minus V will be equal to I into R. See this one I just mentioned here, from this concept we are going to find out what is R here. From this one R is equal to E minus V divided by I here. See from this one E here is battery potential, that is about 1.5 minus this one barrier potential what they have given here is 0.3 divided by 100 milliampere. This one current here is 100 milliampere, milli means 10 power minus 3 will be there. See from this one 1.5 1.5 minus 0.3 here is 1.2, and this one 10 power minus 3 if it is comes here 10 power 3 here and divided by 100. See in this one divided by 100 here is this 2 will be cancelled here, only 1 is there, this is 10 square. See from this one what you are having here is 1.2 into 10, that is about 12 ohm, that is about the resistance here. So answer in this case here is 12 ohm. An ideal PN junction diode can withstand a current up to 10 milliampere. See this problem, don't confuse with this. This problem and last two are similar concept here. See in this one PN junction diode with the 10 milliampere under forward bias. So current has been given, and the diode has a potential difference. The diode which is having a potential difference here is 0.5 volt across it. Across the diode what they have given here is barrier potential they have given, which is assumed to be independent of current. So that's what this is the thing, independent of the current. What is that potential? That is about a barrier potential here. What is the maximum voltage of the battery used to forward bias the diode when the resistance of 200 ohm? See here resistance here is 200 ohm. See first case we have find the current value, and the second case we have find the resistance value, and third case we have going to find out the battery potential. Now to understand this one better, I just draw the diagram and I'll show you here. For this one, first one here is you are having a PN junction diode. This one I just mentioned here, PN junction diode, and connected with the external resistance. And this one which has been given to a potential, external potential. What they have given the value here is this one we are going to, we have to find out what is the external potential here. The barrier potential here is 0.5 volt, and the resistance what they have given here is 200 ohm. So this is 0.5 volt. Similar concept here is V is equal to I into R. Hope you remember this one. This is about the uh, battery potentials, and this is your barrier potential will be equal to I into R. See, from this one V values only we are going to find out. From here V plus I into R, and V values what they have given, the V value here is 0.5 volt plus current value here is 10 milliampere. So I just mentioned here 10 into 10 power minus 3 ampere of current, and the resistance what they have given here is 200 ohm. See, they have given this one. From these two cipher you can reduce this one. This is minus 1, and this one will be cancelled here. So what you're going to have here is 0.5 plus 2 into 1. See here, this is 1 here and this one here is 2. So what you're going to have here is 2.5 volt. That is about your battery potential. So answer here is 2.5 volt. Here is find the current through the resistance in the circuit as shown in the figure. This is about the ideal diode. Remember this one. This is quite interesting, but the simple problem in this one, let me tell you here. To understand this one, I just show you the diagram separately here. See, from this one, see, for this one, this diode 1 and 2 here. See, I just mentioned it. This is first diode and this is second diode here. Now see, this is about the battery. This is positive and negative terminal of the battery. See, positive terminal of battery is connected to P type of semiconductor. Remember here, this is P type semiconductor and N type semiconductor. This is PN junction diode. P type of semiconductor is connected to positive terminal of battery, and N type of semiconductor is connected to the N terminal. N type of semiconductor is connected to negative terminal of battery. So this is called as forward bias. Similar, this one is also called as forward bias. Forward bias, what do you mean that forward bias means? It allows the current to flow across the diode. Reverse bias means it doesn't allow the current. The main function of the diode here is it allows the current flow along only one direction. That is the important concept here. What about the diode? If they are asking here the question in this case, diode, it allows the current only one direction. If it is in reverse bias means it doesn't allow the current. That's all concept here. For this one, see, 2 volt of potential has been given here. Is there is a flow of current here. See, I just mentioned here. In this way, electron will be moving here, and opposite to the direction there will be a flow of current. See, from here to here, electron flows will be there, and current will be moving in the opposite to the direction I just mentioned here. So from here, current will be moving towards here, and that means this is forward bias. At the same time, this one also forward bias here. So there is a flow of current. See, from this one, what you are going to have here is there is a flow of current over here. See, from this one, see, I here is what you are having here is I is equal to, that one we are going to find out here. I is equal to, according to Ohm's law, V is equal to I into R. I is equal to V divided by R here. See, from this one, V is about the potential 2 volt and resistance here is 2. So from this one, I here is 2 ampere of current. So here answer in this case, I is equal to 1 ampere current. Also similar like a previous one, but only one few concept you just try to understand here. And remember always Ohm's law. See, current flowing in each of the following A and B respectively. Current flow in each circuit. Remember this one. Have to find out here. For this one, let me tell you here. In this case, see, this one, these two are diodes. Even this case, two are diodes here. For the first diode here, this is P type and N type of semiconductor. P type is connected to positive terminal, N type is connected to negative terminal. So this is forward bias. It allows the current. Similar, this one also. This one is P type is connected to positive terminal, N type is connected to a negative terminal. This one also forward bias. In both the case, forward bias, it allows the current to flow. So current will be moving from I will be moving towards here. From this side it is I1, from this side this is I2. Again it will come over here like a I current. This is about the potential and this is about the resistance. These two resistance are connected in parallel. Okay, now this is one more concept. Let me tell you here. In this case, we are going to find out what is the current in the first circuit I just mentioned here. See, first one, current circuit V is equal to IR, I is equal to V divided by R. This is the concept here. For, see, in the first case, both the resistance are both are forward bias, so there will be a resistance for this one. RP is equal to, this one here is 1 by R1 plus 1 by R2 here. See, both are same resistance in this case. So RP is equal to, this is the concept here, 4 divided by 2, that is about 2 ohm. So R here is 2 ohm. From this one, you just find out here I is equal to potential here is 8 and resistance here is 2. So what you are having here is 4 ampere of current. For the first case, I is equal to 4 ampere. Now coming to the second case here, this one, the same one, this is forward bias, but this is reverse bias here. So there is no flow of current across this one, only flow of current towards this. See from this one in the second case I just mentioned here. For the second case here is now this one again the same I just mentioned here. Uh, See I is equal to V divided by R, and this one V here is potential again the same 8 and R here is only one has been going towards here. Current will be flowing towards this direction. This is reverse bias characteristic. See here, negative terminal of battery which is connected to the P type of semiconductor, positive terminal of battery which is connected to N type of semiconductor. So this is reverse bias, no flow of current, only flow of current over here. See for this one I just mentioned here 8 divided by resistance here is 4. So what you are going to have here is 2 ampere of current in the second case. So first case here is 4 ampere, second case is 2 ampere. So answer here is 2.51. Sorry, 4 ampere and 2 ampere. Question here is this one the potential difference across the diode is, see this one here is they didn't mention about anything about the potential and current and all here. They are asking about what is the potential difference. If they are asking about the current and what about the resistance like that, if they are asking means you can utilize the Ohm's law. But this one here is this is a theoretical one, direct theory problem here. See for this one potential difference across the diode in this case, in case of silicon and germanium I just mentioned here. You see for in case of silicon, the value barrier potential here is I just mentioned here, silicon barrier potential here is 0.7 volt. For in case of germanium, the barrier potential here is 0.3 volt. Always remember these two values. This is the theoretical value, that is about the barrier potential or the potential difference across the diode. For this one you just mentioned here, silicon diode is under forward bias. In this case of silicon, which is having a barrier potential is zero point 0.7 volt, the same the potential difference across the forward bias also the same. Suppose in case of germanium, remember this one, this is zero point 0.3 volt. Here is the current flow through the resistance in the given circuit. See already they have given barrier potential of silicon, they have given zero point 0.7 volt. Suppose if they have changed this one, let me tell you the concept first. See this one, there are two diodes, both are silicon diode which are connected to here is, see P type of semiconductor is connected to positive terminal, N type is connected to negative terminal. So both are conducts the current, both are forward bias. See in the forward bias there is a flow of current over here. So what they are asking here is the current flow in the circuit. See this one, similar concept according to Ohm's law I just mentioned here. From this one I just mentioned, in this case V is equal to I into R. So they are asking about current I is equal to V divided by R. See for this one, potential in this case I just mentioned here, I is equal to, see already you know this one, in the previous case we have seen E minus V, that one will be equal to I into R. See in this case both are connected in parallel. In this is like a resistance you just consider here. See this diode which is having a resistance, in this case both are connected in parallel, so the potentials will be the same, only the current will be varying here. So potentials will be similar in both the case, both are having a 0.7 volt, so potential will be the same. See from this one I is equal to, here is potential here is 10, 10 minus here is barrier potential I just mentioned as 0.7 divided by resistance, what they have given here is 2 kilo ohm, that is 2 into 10 power 3 ohm. See from this one I just mentioned here, 10 minus 0.7 here is 9.3 divided by 2 into 10 power 3 I just mentioned as 10 power minus 3. So 9 divided by 2.3 here is 4, balance is 1.6 and balance is 1, so this one 5. So into 10 power 3 here is milliampere of current. So in this case answer here is 4.65 milliampere. So this is an important one, already they have asked in the previous question paper for the NEET. See for this one, calculate the value of V naught and I see calculate the value of output. See here, this is about output voltage and the current. If the silicon diode and germanium diode starts conducting at a 0. See, this is 0.7 volt barrier potential and this is about zero point 0.3 volt respectively in the given cycle. First one, both are conducts the current, both are powered by us. In this case, what is V naught and I1? First case. The second case, if this one germanium connection has been reversed. See, in this case, this one is zero point 0.7, this is zero point 0.3. Germanium is reverse. Reverse in this case, this will become reverse bias. What will be the new value of V naught and I? See, for this one, let me tell you, just concentrate here as the given circuit. See here, in this case, the voltage V, see this is about the potential here 12 volt and the resistance what they have given here is 5 ohm, and the current in this case, see here, this one is zero point 0.3 volt and this one is zero point 0.7 volt. You just concentrate why they have mentioned only. See, according to the Ohm's law, hope you remember this one, E minus V is equal to I into R. From here, I is equal to E minus V divided by R. We used to mention this one in the previous problems and all. You just go through on that one. See, from this E current I is equal to, this is 12 volt and only zero point 0.3 volt. Hope you remember this one. In this case, why they have mentioned only zero point 0.3 volt, that is about germanium, not about the silicon here is. See, the effective potential barrier here is, see, this is little more barrier potential, this is less barrier potential. See, even while driving, we always prefer the easiest to route, right? See, this is zero point 0.7 barrier in this case that try to prevent the further movement of electron and holes, but here is zero point 0.3 only. When compare these two, this is little easy to cross. So this is zero point 0.3 volt and this is zero point 0.7 volt. So always the current will always try to follow from the high potentials to the low potential. See, zero point 0.7 and zero point 0.3, which is having low potential, is germanium low potential. So immediately it will be current will be travel towards this direction. See, from this one. So here there is no potential will be moving over here because this is less potential. Current will also always prefer the easiest route. So for this one, 12 minus zero point 0.3 divided by 5, what you are going to have here is 2.34 milliampere. You just simplify this one, you can understand here 2.34 milliampere here. And next one, output voltage. See, for this one, V is equal to R into I. V values is there, I value we found out from this one. From here, what you are getting, the output of the V naught here is 11.7. So this is for the first case, and second case here is if germanium is reverse in this condition. So you are going to put like this. See, in the reverse bias condition, there is no flow of current. Even here is reverse bias in this case. So the current will be moving towards only on this direction. See, for this one here is similar concept I just mentioned here. 12 minus zero point 0.7. What you are getting here is, this is 2.26 milliampere, and substitute the I value here and the resistance also the same. What you are getting here is 11.3 volts. So in this case, 2.26 milliampere is the current, and in this case V naught value here is 11.3. So that's all. This is already previously asked the question. You just concentrate this one little more because this question they used to ask.